Hey, it's Professor McStud, and we're talking about difference of squares. Remember, difference of squares, you have kind of a special setup here. You have a difference, that's the key thing, so it has to be subtraction, and you have two perfect squares on each end. So when you do this, you find the square root of the first one, and you find the square root of the second one. So the square root of the first one would be 2z and 2z, and the square root of the second one is 3. And a plus and a minus. So there's some different things that go into that. Remember, that's like 0. So this would be kind of be a 0 or 4z squared plus 0z minus 9. So it's kind of sort of how that works out and going through there. And so that's where that's factoring part is how we get this kind of common difference, or this common factoring part that is what we have here for this polynomial. All right, so you'll look here at the second example. Moving on, we're going to find the square. Notice the difference, and each of these are perfect squares. That's the key here to identifying this. So the square root of the first one is 4x, and the square root of the second one is 9. So then I have 4x and 9 plus minus factored by difference of squares. Now let's look at this third one. You'll notice that on this third one here it's a plus sign. This is not the sum of two squares. So this one right here, as far as everything that we know, this is going to be prime. Now this doesn't have a common factor. If it had a common factor, we could factor that out. But there is no common factor here between 4a squared and 25b squared. This one is considered prime. So it only works with a minus difference of two squares, not the sum of two squares. All right, and then on the last one here, you'll see that, notice that we have two variables, and that's okay. Remember, we find the square root of the first one and the square root of the second one, and that goes first in the first and second terms in my factors here. So the square root of the first one is 1/3 c. So take the square root of the top, square root of the bottom, that's how I got 1/3. And then 1/3 c, and then the square root of the second one is going to be 8d and 8d plus minus, there it is. So it still works out, even when you have two variables, that's okay. We're just gonna go through and you have to add those variables in. Make sure that this is a d squared, and this is a c squared. That has to happen as well. So just two variables doesn't make it necessarily true. This has to be squared because I have to have a d here and a d here. So be very careful when you're working those out. Make sure that you have a minus sign. Make sure that the first term and second term are both perfect squares. So that's factoring the difference of squares. Remember, difference, it has to be subtraction. That's key. All right, that's what I got for you. Difference of squares, and Professor McStud is out.